Okay. Now in section 2.2, we're going to learn a little bit more about functions and their graphs, and we're kind of going to look at the slope of these different graphs of functions. And so the key to finding the slope of a graph is called the difference quotient of f of x. So for a function f of x, the difference quotient is f of x plus h minus f of x all over h. And this is going to be key to finding slope, or the average rate of change of the function f of x. And so this is really important if you're thinking of a function that's modeling things like the stock market or modeling temperature. You want to know, is this going up or is it going down, and then how quickly is it going up or going down. Okay, so it's always the same process for evaluating a difference quotient. You're always going to write down f of x plus h minus f of x all over h. You need to write down this definition every time you do a difference quotient because it will remind you exactly what to put in each step. And so what this is saying is you should write down f of x and negative f of x, and in the first copy you should put in x plus h, and in the second copy you should put in x. So let me just do this really quickly. I'm going to put parentheses here. I'm going to write down my function, which is 6 times something squared plus 2 times something plus 1. And I put the parentheses there instead of x because I'm going to be plugging in something there. And then I'm going to put a minus sign, and then I'm going to just put a second copy of the same function. So you can either duplicate it if you have a computer, or you just write it all down again. Okay, so this is 2 copies of the same function, and I'm going to put the whole thing over h. Now in the first copy, I want to plug in x plus h everywhere. So anywhere where there was a parenthesis, I plugged in x plus h. In the second copy, I want to plug in x. So I plug in x everywhere there was a parenthesis. And now we're going to simplify as much as possible. So to do that, let me copy down the first function as 6. And since I'm going to be foiling, I'm going to write this as 6x plus h times x plus h to help me foil that x plus h squared. And then I'll distribute the 2 into the x plus h. That's 2x plus 2h plus 1 minus 6x squared minus 2x minus 1. And so to get that minus everywhere, I distribute that negative sign into all 3 terms there. Okay? And that's going to be all over h. And now I get to cancel a whole bunch of stuff. I get to cancel the negative 1 with the positive 1, because 1 minus 1 is 0. 2x minus 2x is 0. And eventually I'll get to cancel that negative 6x squared, though I can't do it quite yet because I need a FOIL. So when I FOIL the when I FOIL the x plus h times x plus h, I get 6 times x squared plus 2x times h plus h squared. So that's the foiling, and I still haven't distributed that 6, so I need to put parentheses around that. And then it's going to be plus 2h minus 6x squared all over h. And now when I distribute this this 6 in to the thing I just foiled, I'll get 6x squared plus 12xh plus 6h squared minus 6x squared over h. And now I get to cancel that negative 6x squared with that positive 6x squared. So I'm left with 12xh plus 6h squared I missed this. I forgot that 2h was there, so this should have been right here, plus 2h. I almost forgot to write that down. So I have all of that over h. And now I'm going to factor out an h, because if you look at the top, every term has an h in it, so I get to factor. I get to factor out an h, and you can always do this when you're doing difference quotients. So I'm going to get 12x plus 6h plus 2 times h over h. And now you can cancel the h over the h, because that's the same as multiplying by 1 over 1. Think of this as h over h equals 1. So this is like 12x plus 6h plus 2. As long as h is not 0, the h divided by h is 1. So it's like multiplying by 1. So my difference quotient here is 12x plus 6h plus 2. And that's the final step there. And like I said, this is the average rate of change over an interval of length h, which I'll explain a little bit more about that in class.